Welcome, viewers, to HVAC 101. Now, it's a few reasons why I'm making this video. And it ain't just me, there's an instructor and a student that's helping out on this. Is that we got so many technicians out in the field that are parts changers, that are guessing what to do when it comes to wiring up an air handler and making things work on a unit. Well, this video right here is going to help try to simplify what you're really doing, why you're doing it, and that way, when you go to work on one, you know really how to do it and save you time, and you can make more money. The other reason is to help future technicians actually learn and perhaps study this to help them better understand how a furnace works so they can wire it up and make it work. Now, this description or what I'm showing you of a furnace, it's not that you're going to see this on every furnace that you go to. If you learn this right here, when you go to a furnace that's different from this, then you'll understand what it's doing. And you'll know how to make it work if you just learn this right here. Now, this is going to be a simple furnace that we're going to do, a basic furnace, but many furnaces have these components that we're about to discuss and learn how to wire up. Today, we're just going to focus on how to wire up this furnace from a board. And every mark that I make represents a wire. So remember that. When I make a mark from here to here, that means a wire goes from here to here. Okay? Certain wires are color-coded. And we'll discuss and mention those type of colors, but I don't have every color for every wire. Now, if you look right here at the furnace, this is a basic furnace. This is what you're going to see a lot of out in the field. This is the blower motor. We're going to talk a little bit about the blower motor. It's in the squirrel cage. We're going to talk a little bit about what's supposed to go here. In fact, everything up in here is what we're going to talk about on the board today. And if you follow this video and watch it and take notes and practice, you'll be able to wire up a furnace, hopefully. Now, what I would advise you to do, if you're watching this video, is to make you a little drawing like what I got here on the board. It don't have to be perfect, but practice drawing it. And that'll teach you how to follow a schematic or a diagram. I got my little drawing here. It's not perfect, but it's enough to practice by. So let's begin. Well, you have two things when it comes to wiring up a unit. You got high voltage and you got low voltage. Always do one or the other. Don't do one. Don't hopscotch like one instructor used the terminology. Do low voltage, get it out of the way. Do high voltage, get it out of the way. Everything has a system. Okay? So have a system when you go to wiring up the unit. Don't just jump around, because you could leave a wire off and don't know it and cause something to go wrong or waste a lot of your time. Now, so we're going to start off talking about the low voltage control before we start wiring up this unit. Well, what is the switch? The only switch in low voltage? Well, it's the thermostat. Now, I don't have a thermostat here on the table, but many of y'all seen thermostats. If you don't know what a thermostat is, I haven't seen a thermostat, then this video is not for you. But a thermostat, and this represents my thermostat in this drawing up, or where we will hook the wires up that will in the furnace that will go to the thermostat. Usually it'll be in a little brown wire, little fine 20 gauge or 8 gauge wire. So this represents my thermostat where it'll be hooked up at. In later videos, when I show you how to wire up a furnace, you'll actually see those wires and you'll see where it's being hooked up at, and you'll actually see the thermostat itself. The next thing in our low voltage, and we're talking about low voltage first, this is our switch to thermostat and low voltage. But where do the power come from for the low voltage? Well, all the power comes from the main power of the building, or home, or whatever the case may be. But the transformer is what reduces that power. It takes the main power and reduces it or steps it down to 24 volts. Now we know in electricity, as long as it is within 10%, is good voltage, we can use it. But if it's below 10%, give plus or minus 10%, then we can run into some problems. So let us get power over here to our transformer. Okay? Notice it's got two legs of power to our transformer. Now, here's a picture, or here is rather, a transformer. It's a little taped up, still good. But you notice it got 3 connections on one end and 2 on the other. These are different taps. The 2 taps, if you read inside of the transformer, is usually your 24 volts. Some will have wires coming off that you hook up to. Some will have male connectors that you will plug a female connector over. On the bottom, we have a common, we have our 208 tap, and we have our 240 tap. You need to read whatever transformer it is, make sure you wire it up correctly. Some will have a 120 tap, and they have different colors for each tap on the ones that use wires. So you need to be sure, because if you wire up a transformer wrong on either end, you can cause your controls or either the transformer itself to blow. So it's very important. In this building right here, we use 208 voltage, not 240. So if I was wiring up this transformer, I will wire it up with 208. I will use common plus the 208 tap. If I was in a building that used 240, I will use common plus the 240 tap. Well, anyway, we'll wire our transformer up, and now it will step down the voltage to feed our low voltage controls. Now, what are our low voltage controls? Well, your low voltage controls in this drawing is your sequencer and your fan relay. I repeat, your low voltage controls is your sequencer and your fan relay. These are the basic controls or low voltage controls that you're going to see in most furnaces. They may come in different sizes, different types of looks, but they don't always have something that would do these things. For instance, the sequencer will always pretty much control your heat strips. Now, in the heating mode on some units, it may control your heat strips as well as your fan. Your fan relay will, for the most part, live up to its name. It will control the fan. So we're going to talk about how these things control. But first, let's start by looking at the sequencer. Now, that is just a drawing of a sequencer, a pictorial drawing, but here's an actual packaged sequencer. Sometimes they come in tubes, you can get them individually, but if you look at this packaged sequencer, it's got several different circuits. Now, I'm going to pull back over here towards the board, hopefully you can see this, but this sequencer got one circuit up top, and it has another circuit in the middle, and then at the bottom it has another circuit. Well, the low voltage is always at the bottom. And then I only put one circuit on this for this drawing, but it could have another one. So each one of these circuits can control a different heat strip. Now, one thing about the sequencer, it is a time delay device. It consumes 24 volts at the bottom, and as it generates heat, it slowly moves and closes the contacts in the sequencer. The purpose of having a sequencer or a time delay device to control the heat strips is, you ever went inside a home and when the units start up, the lights in the house dim? Well, it's drawing too much current. All the heat strips are coming on at the same time. So the purpose of the sequencer is each one of these circuits comes on or closes at a different point in time. So to allow a different heat strip to come on at a different point in time. Now, there's ways of reading the heat strip and lets you know how much time it will take for it to close and how many seconds it will take for it to open. So it depends on that particular sequencer. They usually have a C for closing, and it'll let you know. And H will let you know how long it takes to open or close. So just keep that in mind. But that's not really super important as long as it works. Most of them will do what they're supposed to do. So the sequencer is going to control our what? Heat strip. Our fan relay is going to control what? Our fan. Now this is the drawing of our fan. This is how I like to draw it. But there's other drawings of fans. In fact, there's other drawings of the sequencer and the fan relay. but you'll be able to recognize those things once you understand this video. Now, see the fan? Here's the fan right here. So just keep that in mind. The fan is in our furnace. But back over here to our fan relay, look at our fan relay. Notice that it has, on this particular fan relay, we call it a switching relay. Some call it a switching relay, some call it an 8-pin relay. But we have here one circuit, two circuit, another circuit. Low voltage on the bottom, and then we use this circuit to pass power. It can pass low voltage and it can pass high voltage. But for the most part, it will be controlling high voltage. So we call our fan relay and our sequencer our low voltage controls in low voltage, or we call them our low voltage loads. But in high voltage, we call our sequencer and our fan relay switches. Yes, there are switches for our high voltage because they control high voltage loads, the heat strip and the fan. Now, here is some fan relays. And we're just going to discuss some of them, but there's many of them out there, but they all seem to have the same purpose. They're all going to have some normally closed switches as well as normally open switches on them. Normally closed and normally open means in their off position when they're not being energized, they're going to be either normally closed or normally open. Some will have little markings like this. That means normally closed. Some will have markings like this. That means normally open. Okay? And it may have NC or NO. In fact, for learning purposes, I'll write that on here. This is NO. This is NC. This is NC. This is NO. Pause this for a minute.
Okay.
Hit pause.